Okay, welcome back. Now what we're going to do is we're going to start going over the irradiance particles, and we're going to focus more on the interpolation side of irradiance particles. We already saw how IP works when using the brute force method, which is very slow to render, although very accurate. We're going to use interpolation now, and we're going to lose some of that accuracy, but to be honest with you, it's not going to be readily visible to the naked eye, so we can get away with it. So let's see how we can do that to render out irradiance particles faster. Let's open up an example scene. Let's start off back again with the IP start scene. So let's open that up. And here we go. If we do a test render really quick, this is what we get. Just simple room again with an area light on top. There's no indirect illumination at all. In other words, IP's turned off. So let's go over here to our renderer options. And let's go to our photon global tab and switch to Irradiance Particles. Go back to the Irradiance Particles tab and turn on Irradiance Particles. I'm going to lock that down so it doesn't go anywhere on me. I'm also going to go ahead and open up my script editor over here, set it up as usual. Okay, let me go to diagnostics and turn information on. Very important. You need to know what's going on under the hood of mental ray. And that's pretty much going to do it. Okay, now we did see in an earlier video how to render out using default settings. We just turned on radiance particles and then we hit render. The render took a really long time and the quality was pretty decent. It was pretty acceptable, but that's not exactly the best way that you want to work with irradiance particles. So I'm going to show you here how to do that, how to work with it a lot better using interpolation. Okay, the default settings are too slow. They're not optimized. They're not set up correctly in my opinion. So we're going to go ahead and reduce some of this stuff. The first things that we're going to do to reduce the render time is to take down the number of rays. Let's take the rays down to something like 32. A very small amount of rays. It's going to give us a lot of artifacting and not exactly the best quality images, but it's going to be perfect for test renders. For interpolation, we're going to leave the always mode turned on. We don't want to use never, and we don't want to use for secondary rays only. We want interpolation all the time. We're also going to reduce the number of points down to about 32, and we're going to turn environment off. We'll talk about environment in another video, but not in this one. Then we'll go over here to the photon tab here, and for the importans, we're going to reduce the number of importans by a very small amount. Let's just take it all the way down. And 0.5 is not the lowest we can go. We can actually go to 0.02, and that's going to give us a small amount of importans. And by reducing the importans and reducing the number of rays, we dramatically reduce the render time. So this is going to be good for doing preview renders. Okay, so let's get going here. Going to do a render preview here. And there we go. There's the irradiance particles. Very, very fast render. Okay. Wall clock says took only about 3 seconds to render this out. And if we scroll up here, we can see that the importans was about 2,752, which is a very small amount of importans, which explains why this thing rendered out so quickly. Okay, so what's going to change the quality from this? Let's lock this render down. You can see in this render we have a lot of blotching, a lot of color splotching. Looks very reminiscent of using photon mapping with global illumination, or even using final gathering with low settings. Okay, but to get a similar result like this with global illumination and final gather settings probably would take a lot longer than 3 seconds. Okay, so you can already start to see how radiance particles is much faster even when doing preview renders like this. So to start to increase the quality of this, what we need to do is make some changes to our accuracy settings as well as our importans. But one important thing that I want to point out to you right now is that the importans work based on the image resolution. Okay, so let me try to explain this while showing you an example of what it is that I'm talking about. If you look up here in my render preview window, you'll see that it says 450 by 304. Those are the dimensions of this render. This is a 450 pixel wide by 304 pixel in height image. Okay, now the way that the importans work, the density parameter in particular, is based on the resolution of your image. In other words, if the image is small, you're going to actually shoot out a small number of importans. If the image is huge, you're going to shoot out more importans. So if you don't really understand what I'm talking about, I'll show you a demonstration here. I'm going to take the density and I'm going to set it to 1. 1 is a very high value. What 1 means is that 1 important will be fired off for every pixel in this image over here, and the image is 450 by 304 pixels. Okay, so this basically means one important will be fired per one pixel. Now, to give you a really good idea of what that means, okay, what that means is that this image here, you can figure out how many importans are going to be fired out when it's set to 1 based on the resolution. So if we took, say, the calculator here, okay, and I take 450 and multiply it by 304, that's going to give me a grand total of 136,800. Okay, 136,800. Let me go down here to my script editor. I'm going to write that down. 136,800. Okay, importance. So let me clear out my script editor here. Now, if the density is set to 1 and no trace depth, no diffuse bounces, I'm going to go ahead and render this out again. And we're going to fire off a lot more importance, and we're going to see in a few seconds down here in the script editor how many importance. Okay, so there you can see the number of importance is 136,800, the exact number that I calculated over here. Okay, so that should make a lot of sense to you and should demystify something about how these importance work. So let me just cancel that render out and go back over here to importance. Now, when we increase these diffuse bounces, we'll actually end up creating a lot more importance. Okay, so I'll increase the diffuse bounces by 1, just 1, which doesn't seem like much, but it's actually going to increase the importance by a good amount. And I'm going to refresh that. And let's just wait till it finishes emitting these importance. Okay, so there you can see that the number of importance increased to 228,370. That's a pretty high increase. That's an increase of almost 100,000 importance just by increasing the diffuse bounce by 1. So imagine if we increased it to 2 or 3 or 4. Because what's happening is that the importance are bouncing around in the scene, so it means that more importance are being created because we have these diffuse bounces set to a value that's higher than 0. So if it's 1 or 2 or 3, that means there's more importance bouncing around, which creates more importance in the scene overall, which, of course, as you can imagine, increases rendering time little by little as you increase these diffuse bounces. Okay, so you want to be aware of that and make sure you know you understand how that works. Okay, so what I'm going to do is I'm going to knock this density back down to something pretty low. Let's try something like 0.05, and I'll take the diffuse bounces, knock that down to 0, and I'll refresh this. Now we're doing about 6,868 importance there. Let me just go back up here. There it is. 6,868 importance is what we're doing right now. Okay, which isn't really a lot, which explains why this thing rendered out in, according to the wall clock, 6 seconds. Extremely fast. Okay, so we have some indirect illumination coming in pretty quick. So what I'm going to do is I'm going to increase the amount of importance to something closer to about 10,000. So let's go to maybe 0.07. Yeah, let's try that and see. Let's refresh that. There it goes. It's going pretty quick. It's not taking too long to do these preview renders. Okay, that one was an 8-second render. I mean, come on, you can't complain about that. And we did about 9,520 importance, which is good enough in my opinion. So we'll leave that alone. Now we'll come over here to the Irradiance Particles tab. Now we can see the type of noise and artifacting that there is in our image, which obviously is unacceptable. So to start to get rid of some of that stuff, what we need to do is start to increase these rays. So right now our rays parameter is only 32, which is a very small amount. So what we're going to do is increase that to about, let's try 64, so we're going to double it. And I'll do a separate render so that we can compare and contrast the two when this one's finished, which shouldn't take too long. It's already computing the final irradiance pass. So in a few more seconds it'll be finished. There it goes. Okay, so this one took only 14 seconds. That's not bad. And you can see a lot of the artifacting and blotchiness went away, although we still have some of that left. So basically what you want to start doing now is just very nice and easily increase these rays. Don't go too crazy with it. Don't raise it too much. What you want to do is try to squeeze out as many rays as you can to increase the quality of this without overdoing it. Because if you overdo it, the quality isn't going to look that much better. Instead, your render times are going to shoot through the roof, so you want to be careful about that. So let me double the rays from 64 to 128. Let's go ahead and render again. Okay, so that took 22 seconds. So it went up from 14 seconds to 22 seconds, which is really not that bad. That's what, 6, 7, 8 seconds. So we got an 8-second increase in render time, but our image looks pretty good. Look at that. A lot of the artifacting and blotchiness went away. Although we can still see some slight artifacting, it doesn't look very accurate, and it doesn't look that great. Okay, so what I'm going to do is I'm going to maybe increase this a little bit more. So let's increase it to about maybe 256 rays. And let me see, that's pretty much all I'm going to do. So let's go ahead and refresh that. Okay, so that render about doubled. The render time went from about 22 seconds to 40 seconds. So the render time pretty much doubled. But that's still not too bad. I mean, this thing rendered out in less than a minute. So that's actually pretty good. So we're actually getting a very good indirect illumination result here. As you can see, we do have some color bleeding. It's looking pretty good. I mean, we do have some artifacting. That's mainly due to the fact that we're using low anti-aliasing settings as well as low sampling settings for the area light on the ceiling. But in terms of the indirect illumination or the radiance particles look, it actually looks very good. I don't really see any artifacting or any problems. Okay, and right now we're using a point interpolation of only 32. We can actually raise that. So that's actually what we're going to do. But before I do that, I want to go ahead and show you something really neat here. Let's turn rebuild off. By turning rebuild off, the map won't go ahead and regenerate every time. I can refresh this render and it'll keep reusing the same map, which is simply fantastic. Okay. One thing that I can do is I can increase the amount of points with this thing turned off, basically with the map frozen. And the cool thing is that some of these parameters continue to work and make changes even after the map is frozen. The raise parameter will not update when you freeze the map. So if I take this raise and increase it like so and refresh, it won't make a difference. So some parameters can be refreshed when the map is frozen and some cannot. So I'll show you very quickly the ones that you can refresh when the map is frozen. So these are some of the parameters. In the accuracy setup here, you can't do anything with a rating of indirect passes or rays, but you can increase the intensity. So I can actually take this intensity and knock it all the way up to 5, and I can do a new render, and you can see that the new render has a higher intensity for the irradiance particles. It looks a lot brighter. So it's very cool that you can update and make changes to, say, the intensity without having to rebuild the irradiance particles map and wait 40 seconds for it. You can actually render it out in about 1 to 2 seconds. Okay, so let me go back to the default. Interpolation you can also change. I can actually come in here and change the interpolation, turn it off, and do a new render. And the problem with doing that, of course, is that it forces the brute force method to work instead of interpolation. And as we've already seen from a previous video, using brute force is not the best way to do this because it takes longer to render, although it does yield the best accuracy. So let me just go ahead and cancel that render out. I can also switch to interpolation for secondary rays only, which for most cases I don't recommend because it's slower than using always, the always mode for interpolation. It's just kind of a blend between using interpolation and using the brute force method. But I find that this option here is not the best. As you can see, it's still taking a long time to render, and the results are a bit grainy if you're using only 256 rays. So I'll switch back to always. Another thing that I can do is change the point interpolation down here while the map is frozen. So as you can see, our original image here, let's just refresh it, is using only 32 points. I can actually reduce those points all the way down to only 3 and render again. You can see now we have some little bit of noise and artifacting here, a little bit of blotching and stuff. That's because we reduced the noise, or I'm sorry, the points. But we can increase the points to say 128, and then we can render again and get ourselves a very nice render. So look at that. That looks pretty good. And it looks almost as good as the first render here on the left. But smoothing that out can get rid of any artifacting that you have, if you have any. In my case, I really didn't have any, but I'll leave it at 128 points right there. Okay, so those are all the parameters that you can change with the maps frozen, so you don't have to rebuild the IP map over and over and over again. Okay, so we got ourselves a pretty good quality image. This right here is one way of getting yourself a pretty decent quality image with these settings. As you can see, we were able to render out much faster than using the default settings. Let's do one more tweak. Let's add an indirect pass. So I'll add an indirect pass. I'll keep the rays at 256. Interpolation is good, and the number of importons is good. I'm not going to add any diffuse bounces because that's just going to go ahead and add more render time, which I don't want. And right now my density is set to 0.07, which comes out roughly to about 10,000 importons, which actually looks pretty good for this scene. Doesn't look too bad, okay, for this simple still render. So now that that's done, I have to turn rebuild on because I added an indirect pass, and indirect passes require you to rebuild the map. Okay, so let's go ahead and refresh that. So there it is, about 9,520 importons. And I'll just skip ahead so you don't have to watch the rendering process. Okay, so there it is. It finished. It actually rendered out in a total wall clock of 1 minute and 20 seconds. Only 1 minute and 20 seconds to render out a pretty decent IP map. Now, one thing to take note of is that these settings that I used here, although they were pretty optimized, they won't give you the best render if you're trying to render from different camera angles. In other words, let me turn rebuild off, okay? And every time I refresh this, it's going to render very, very quickly, as you can see, in only 2 seconds. We're using low anti-aliasing settings though, and that's one of the reasons why. But if I switch the camera angle to look behind the camera and I do a new render, you're going to notice something very bad here. And what you start to see is that we have this huge problem here. This is not a problem with the room. The room doesn't have this strange geometry to it. You're not looking at a broken ceiling or anything like that. This is actually a problem being caused because the irradiance particles are camera dependent. They're dependent on what's in the view of the camera because they're based on importons, which work based on importance. So it's all based on what the camera sees. So if the camera can't see something, for example, this part of the room which is behind the camera, then that area of the room is not going to have the irradiance particles calculated correctly for it. And of course, that's a serious problem. So how can we fix that problem? Well, I'll show you that in the next video. For now though, I wanted to show you how to get a really fast render with irradiance particles that looks pretty good. Because if we go back to our first camera angle, this irradiance particle solution actually looks very, very good. It's very accurate. You would not be able to get an indirect illumination result this good using global illumination photon mapping or final gathering or both of them together in only what was it, about 1 minute and 20, I believe it was. Yeah, I think it was about 1 minute 20, something like that. Anyway, it took less than 2 minutes to render out this this IP map, which actually looks very, very good. I mean, all we have to do is increase our anti-aliasing settings, and this will look really nice. So you can actually get very fast renders using irradiance particles if you just know how to tweak the settings the correct way. And that's what I think a lot of newcomers to irradiance particles have been having a lot of trouble with and have been getting frustrated with, is the fact that they're not sure how to use the parameters of such a brand new indirect illumination algorithm. But now you know how to do it. Okay, so that's going to do it for this video. In the next video, we're going to focus on the same scene, but we're going to use different techniques to fix specific problems. In particular, we're going to fix this problem back here that we saw behind the camera. We're going to learn how to use irradiance particles to solve this problem behind the camera and get ourselves a really good, high quality IP solution that's good enough to use for animated walkthroughs and things like that, for architectural visualizations and for whatever your projects require. Okay, so I'll end this video here and I'll pick up from right here in the next video.